Welcome back to the deep dive. We're here to, cut through the noise and get to the good stuff. Today, we're looking at something a lot of you might be facing. Upgrading, maybe expanding those existing 1080p HDMI setups. Without ripping everything out, think about it, maybe your business is growing or your smart home's getting more complex. You hit those HDMI limits pretty fast, right? Short cables, not enough screens, just a management headache. So our deep dive today is into HDTV Supply's WolfPack HDMI transmitters and receivers. We're going to figure out how these little boxes work, what they can do, and importantly, what you need to know before jumping in. The mission, to get you well informed so you can manage those HDMI signals over your network strategically.
Yeah. And what's really interesting here is how they target that specific challenge. We're talking about that intersection,
Right.
where traditional HDMI meets network distribution power. It's really about getting more mileage out of your current gear, extending its life, its capability, instead of a massive, expensive overhaul.
That sounds like a smart move, especially if you're watching the budget.
Mm-hmm.
Okay, so let's peel back that first layer. What is this product, fundamentally? It's not a whole kit, right?
No, exactly. It's about individual units, a transmitter or a receiver, standalone. They're designed specifically to plug into, to upgrade or expand an existing WolfPack 1080p HDMI matrix system. Think of them like Lego bricks for your AV setup.
Gotcha. Building blocks. And we're looking at one particular unit, part number HDTVS XEX22. It's running about $200 right now. That price point alone suggests it's more of an add-on, not a huge investment.
Precisely, and that's the strategic advantage, buying just what you need. If you think about the bigger picture, it frees you from those old fixed-port matrix switchers, the ones where if you need just one more input, suddenly you're buying a whole new bigger box.
Right, yeah, been there.
With this, you just add the piece you need. Another source, add a transmitter, another screen, add a receiver. You pop it onto your network. It makes scaling so much more agile, more cost-effective. It basically future-proofs your setup a bit against those growing AV needs.
Okay, so it's more than just an upgrade. It's like evolving the system you have. But what features do these WolfPack units actually bring? What makes this work? Well, first off, they handle the basics. 720p, 1080p HDMI video, plus 2-channel audio. So compatible with pretty much any modern HD source you've got. But here's the bit that caught my eye. Extending 1080p signals up to like 300 feet over a single AT6 or KT7 cable.
Yeah.
That distance using standard network cable?
Yeah.
That's significant.
Oh, absolutely. That 300 feet, maybe 90 meters or so, that capability alone is a game changer for many setups. Think about running video from a basement server room up to a top floor conference room or across a large home. Normally that distance means pricey fiber optics or, those specialized active HDMI cables that can be finicky.
Right. And unreliable sometimes.
Exactly.
Sorry.
Doing it over standard, cheap CT6 or CUMI7, that leverages infrastructure that might already be there. Big, practical win, lower cost, simpler install usually.
Okay, great range. What about controlling things from afar if my source is in the basement?
Good point. The source material mentions two main ways. First, a browser-based GUI graphical user interface. So you manage it from a computer on the network. Plus, they have wideband IR remote control support.
Ah, so I can still use my regular remote.
Yeah, you can still point your Blu-ray remote at a sensor near the TV, and it'll control the player back in the rack, which is pretty handy. And importantly, they mention HDCP 1.2 compliance.
Okay, hang on. HDCP. For listeners maybe not deep in the weeds, what is that and why does 1.2 matter here?
Good question. HDCP is high bandwidth digital content protection. It's like a secret handshake between your source, say your Apple TV, and your display. It's copy protection. Make sure you can't easily pirate protected content. Without it, you often just get a blank screen, even if everything's wired up right.
The dreaded blank screen.
Exactly. So version 1.2 means these units handle the content protection needed for most 1080p stuff. Your movies, your shows, they should actually play without issues.
Okay, content protection, check. Now, you mentioned using the network. That brings us to the core of how this works, right? How do these WolfPack boxes actually use the network? They're not just point-to-point extenders. They use gigabit IP switches for distribution. And the architecture supports different ways of sending the signal, unicast, multicast, or broadcast. That sounds flexible.
It is.
What really stands out is this idea of scalable 1080p broadcasting over a standard gigabit switch, adding more displays, it says, without bogging down the whole LAN.
Yeah, and that's where the contrast with those traditional fixed-port matrix switchers really shines. Remember those? Fixed inputs, fixed outputs.
Yeah.
Here, it's modular, network-based. Need more outputs. Add receivers to the network. Need more inputs. Add transmitters. It's way more scalable. And those traffic types you mentioned, let's break those down simply. Unicast is basically one-to-one, like a direct call. Transmitter A sends only to receiver B. Multicast is one-to-many, but efficiently. The transmitter sends the video stream at once, and the network switch makes sure only the specific receivers that requested that stream actually get it. Think of it like subscribing to a specific channel.
Okay, so it doesn't flood the whole network.
Right, only those who tuned in get it, which is why you can add more displays without killing bandwidth, typically. And broadcast is true one-to-all. Transmitter sends every device on that network segment gets it, whether they asked or not. Less common for video distribution usually, but the option's there.
That distinction, especially multicast, explains how you get that scalability. Very clever.
Yeah.
Now, the term plug and play often gets tossed around, but the source material is pretty clear. There are some serious must-haves for this to work properly. The big one for me was the requirement for a dedicated LAN.
Yes, that's absolutely critical. Non-negotiable, really, for stable performance. And it raises that question. Why? Why dedicated?
Yeah, why can't I just plug it into my regular home network?
Think of your video signals like VIPs. They need a clear path, very sensitive to delays and interruptions or jitter. Your regular network, that's like rush hour traffic. Emails, web browsing, maybe someone streaming cat videos.
Right.
You don't want your pristine 1080p signal fighting for space with all that. A dedicated LAN is like giving those VIP video packets their own private highway. It avoids data collisions, interference, timing issues, all the stuff that causes glitches, dropouts, or instability when you mix time-sensitive AV with general network chatter.
Okay, so keep the movie stream off the same road as the online gaming. Makes sense. And even within that dedicated LAN, it gets specific. No other network appliances, needs its own unique subnet. This is where plug and play starts to feel more like configure and play.
That's a good way to put it.
Because here's where it gets really interesting for the person setting this up. You actually have to configure unique IP addresses and MAC addresses for every single transmitter and receiver. It's not automatic discovery. You're doing this manually. What's the main hurdle people hit with that? Is it super technical?
It's definitely hands-on. The biggest misconception is probably thinking they'll just magically find each other on the network. Modern devices often do that, sure, but for a high-performance system like this, where you need precise routing of specific streams, manual configuration is key for reliability. The challenge isn't usually the difficulty of assigning an address, it's more about understanding why it's necessary and carefully following the instructions.
So RTFM applies here. Read the fine manual or watch the videos as they recommend.
Exactly. They recommend their setup videos for a reason. It's likely well documented because it's a common sticking point. Assigning a unique digital address, IP, and MS just tells the network switch precisely where to send each video stream. And another practical nugget from the source, for CT6 runs, avoid using EZ45 connectors or patch panels.
Ooh, why's that?
They can introduce weak points, potential signal degradation, or failure points. For the best signal integrity, especially over longer distances, you want solid, direct connections.
Good tip.
And for troubleshooting, if you get no picture, first thing to check, those MAC addresses you set up, and your switch port configuration. They also mention if you have trouble logging into the web GUI, try Firefox. Seems it works best.
That Firefox tip alone could save someone hours of frustration.
Yay!
Okay, so those are really valuable practical pointers. Let's say we've got our dedicated network ready. IPs and MACs are meticulously configured. How do we physically wire this stuff up? Okay, the physical hookup actually sounds pretty straightforward. Connect your source DVD player, cable box, whatever, to the HDMI transmitter's input. Then run your TD6 or CoAT7 cable between the transmitter's Ethernet port and the receiver's Ethernet port. And they stress using the EIA-TIA 568B wiring standard for those cables.
Quick note on 568B, that's just the specific order. The little wires inside the cable are arranged in the connector. There's 568A and 568B. For any network setup, consistency is absolutely key. Just stick with 568B for all your cables in the system, and you'll avoid potential headaches later.
Got it. Use 568B consistently. Then, connect your TV or projector to the HDMI output on the receiver. Plug in the power supplies for both units. Seems simple enough. What about that IR control setup?
Also pretty intuitive. You plug the IR transmitter TX cable into the transmitter unit and stick the little emitter bulb right over the IR window on your source device, your cable box, for instance. Then plug the IR receiver RX cable into the receiver unit near your TV and place that little IR eye somewhere it can easily see your handheld remote. On the TV bezel is usually a good spot. So yeah, if we connect this back to the bigger picture, Despite the network configuration needing some care, the actual physical wiring is pretty basic AV stuff. Source to transmitter, network cable in between, receiver to display, plug and power. The key thing to remember, though, is how you control the switching. The source is clear. No physical remote for the matrix itself, no buttons on the front panel.
Right.
It's all done via that web GUI on a networked PC or Mac, either wired or wirelessly accessing the GUI. This really reinforces that it's designed as part of a managed, network-centric system.
That totally makes sense for something built around network distribution and scalability. Okay, let's quickly hit some key tech specs. What are the hard numbers here? Transmission distance, 1080p, 8-bit video, up to 120 meters maximum. That's over a single solid-core 24 AWG KT6 or KT7. So roughly 390 feet. That's even further than the 300 feet we mentioned earlier as a general guideline.
Yeah, 120 meters is the max spec. Impressive.
Video formats supported. Everything from standard def 480i up to 1080p. Power use, super low. Only 3 watts max for the transmitter, 3 watts for the receiver. And operating environment is pretty standard indoor stuff. -5 to +35 Celsius, 5 to 90% humidity, non-condensing.
So what does all that really mean for you? Well, the 120-meter distance, that unlocks installations across really large spaces, places that used to require much more complex solutions. The wide video format support means less worry about compatibility with your gear, and that 3-watt power draw, that's tiny. Lower electricity bills, less heat generated in your equipment rack. These specs aren't just numbers. They translate to reliable, high-quality, efficient performance in, real-world setups.
Okay, so wrapping this all up, these WolfPack transmitter and receiver units, they seem like a really potent, flexible, and pretty affordable way to extend and manage your 1080p HDMI over an IP network. They definitely help you upgrade or expand what you already have, moving your AV distribution onto the network without necessarily starting from zero. That initial plug-and-play feel is there for the physical connections, but unlocking the real power, ensuring it works smoothly, that definitely requires understanding and correctly setting up that dedicated network, especially those IP and MC addresses.
Yeah.
It's a sophisticated piece of kit that demands a bit of technical know-how from the user, but the reward in terms of scalability, reliability, and performance seems pretty significant.
And, this whole discussion really surfaces an important question for all of us to think about. As more and more of our AV gear moves onto the network, our audio, our video control systems, how crucial is it becoming for everyone, from home users to installers, to have at least a basic grasp of network configuration? What does this mean for future smart homes or business AV? Are we heading towards a future where knowing how to assign an IP address is as fundamental as knowing how to plug in an HDMI cable? It really points to this increasing blur between traditional AV skills and IT skills, something to definitely keep an eye on.
That is a fantastic thought to chew on. Where's that line between AV and IT going? Until our next deep dive, thanks for tuning in.